Okay, now that we know we can flip the exponent to the other side, we can do this a lot faster. Don't forget to take the reciprocal of the exponent. Let's see. Negative exponent is 1 over cube root and squaring. So okay. Cube root of 27 is 3, so the final answer is 1/9. If you don't have to turn it into, if you don't have to do it by hand, you just flip the exponent, stuff it into the calculator. Let's see. Okay. The only thing about this is don't forget that if you're just doing square roots, even roots, plus or minus, don't worry too much about that if logarithms are also involved. Let's see. By hand, we'll make them all powers. Let's see, I'll do it this way. Of the same base. Let's see, 125 and 1/5, those are both powers of 5. Should be getting used to this one. 1/5 is 5 to the negative 1. We can still do that. Distribute the exponent. Don't just kill off the parentheses. It's 3x plus 9. And then once the bases are the same, you ignore the bases. Let me write this in blue. So, add 2x, subtract 9, and x comes out to -2. Okay, if you don't have to do it by hand, there's, because 340 is definitely not a power of 12. You can do 2 methods. Method 1, my favorite. Remember, it's ln, not in. Add 7, divide by 2. I'm going to start putting in parentheses because when you type it into the calculator, you need to be careful about that. Okay, I typed in 1 log. I forgot to divide by 2. Hold on a second. Okay. So I start with 12 to the x minus 7 equals 2x minus 7, sorry. That's what I did before. And then the base of the log is the base of the exponent. And then pop across. Something to notice, this and this are the same by the change of base formula. You take the log of the number and divide by the log of the old base, or the ln of the number and divide by the ln of the base. Okay, when you have two different bases and they both have x's, you have to just take the ln or log of both sides. If you can make the bases the same, it's not worth doing all this extra work. But I'm going to do ln this time. We did a practice problem a couple of times doing class notes, but this will have extra words. So one note. You have to pop the addition apart for the multiplication into addition first, because the x plus 1 doesn't involve the 3. So pop only in front of the terms that involve the x. Sorry. Don't forget parentheses. Parentheses, yeah, whatever. So I'm going to distribute the ln 7 to both terms and the ln 3 to both terms. And then the same thing on the other side. Okay, so now what do I have? I have two terms that have x. They need to be on one side of the equal sign. Everything else needs to be on the other side. So I'm going to take x ln 7 minus 2x ln 3. And I'm going to subtract off the two that are on the side that should just be x's. Okay. These two should combine into negative 4 ln 3s. Before you can divide, you need to factor the x out. So x ends up being ln 4 minus 4 ln 3 minus ln 7 over ln 7, because you're dividing by what's stuck to x. Now, to type into the calculator, you not only need to be careful to close all of the ln parentheses, you also need to make sure you put extra parentheses around the top and the bottom. So don't forget that. Maybe I'll color code those. Extra parentheses. So that the division goes okay. And then I stuffed it into the calculator. Let's see if I got it right. You should try it yourself. Complain to me if I did it wrong. Okay. Next. Okay. If you have ln's or logs on both sides, you have to make it into a single ln on one side. Remember, subtraction outside is division inside. Subtraction inside is nothing useful. I just misspelled also. Okay, you can't do anything with the x minus 4 except put it under the x. Multiplication in division inside, addition and subtraction outside. Then we can just compare insides. Cross multiply. So negative 5x is negative 24. Okay. I'm going to distribute the x because it's now inside. Right. Compare the insides. Does this factor? No, it doesn't. Ooh. So opposite of b, plus or minus square root of b squared minus 4ac over 2a. Oh, that's a negative 9, and that makes it real. So 4 minus 36 is 4 plus 36. I can pull a square root of 4 out. Let me write that better. Okay. Okay. Fun factoid. Square root of 10 is approximately pi, 3.16. That's used in the Bible at least once. Okay. A little note for this one. Okay, so since we have an equal sign, we have a couple of ways to get rid of the 3. Don't pop it up. Get rid of it some other way. So subtract 18 first. Oh, look at that. Divide by 3. Un-ln by e-ing the other side. Then subtract 2 and divide by 3. Don't forget to put parentheses if you type it in your calculator. About 400,000. 8 to the 16th is a fairly hefty number. Okay, pop exponents first. This time it does help because they're just numbers. That's a terrible too. Okay, so a little note. Remember, it's 4th root. 4th root of 16 is 2. Expect nice numbers if you're expected to actually calculate by hand. If it says estimate, you know, whatever. 9 to the 3 halves is square root of 9 cubed. Remember, denominator is the root. Square root of 9 is 3, and 3 cubed is 27. Okay, so we'll pop those back in. Oh, I did that. Come on. No, don't go down. I hate it when it does that. Here we go. Because I get my hands all over it. So this is going to be log of 8, see the right side, minus log of 27 plus log of 4 minus log of 9. Okay, positive things go on top. One big honkin' log, don't make it log over log. That's change of base. Eight times 4 is 32. What is 27 times 9? Well, it's 9 times 9 times 3. So it's 81 times 3. Log over log is change of base. It is not just division. Okay, so for this one, remember, logs give you the exponent. So log base 8 of 8 squared is 2. Oh, so that becomes relatively easy. Okay, let's see. What's the exponent? Remember, logs tell you the exponent. So this is log base, oops, let me do that in red. 49 is 7 squared, and the fifth root is the 1/5. Okay, so 2/5. Let's see. Negative for the 1 over, cubing to turn it into 1,000, and square root for is half. Negative for 1 over. Let's see, the power is 3, the root is 4. So, there we go. A few zillion of those. Okay, so level 2 question is just splitting this one up. Lovely. Remember, log base 3 of 3 is 1. Come back here. Come back. No, don't go all the way there. This thing drives me crazy. And then I can't grab it properly. Thank you. Okay, so what about this one? I don't have 2, I have 4. How do I get 2 from 4? Well, it's half of 2, but that doesn't help. Let me just write that down. So I want an exponent instead. So log of 2 is log, how do you get 2 from 4? Oh, square root. Pop. Oh, it wasn't that special. Okay, to change base, use the change of base formula. Okay, so to take the log with a weird base, you just take the log with the new base that you want and divide by the log of the old base. It was log base 3 or 4, 1.2. Oh, that's a terrible one. Handwriting seems to have really decayed. Oops, forgot to type that in. Hold on a second. Okay. Cube root of 20. So, if you remember that part A asks you for the log base 3 of 20, you can use that. So you can do this a few ways. You can do log base, but either way, you're going to need log base 3 of 2. I'll just do 2 cubed. And we already calculated that. There we go. Okay. Last page, yay. So, left 3, down 2. What's the procedure? First, okay, so let me write it this way. So, left 3, we're going to draw the vertical asymptote in left 3. Then 1 unit away, so 1 unit to the right of the vertical asymptote, and then up or down as appropriate. This one says down 4, so 1 unit away from the vertical asymptote. And then last but not least, it's powers of 3. Okay, so let me do this with 1, 3, and 9. 27's too far, so that's the only ones I'm going to plot. Oops, let me make that real. Okay, and then don't let it hit the vertical asymptote. Okay, so the points have to get closer and closer and closer. That's what asymptote means. All right, last one. Let's see. This is left 1, up 4. Let's see. VA left 1, up 4 to the 1 to the right of the VA, and then powers of 2. So 1, 2, 4, 8. Okay, 16. No, I don't have enough room for 16. 2, 4, 8. Again, away from the vertical asymptote. All right, last but not least. Okay, so this is A. This is A, which is the initial value. So and then we plug in the numbers that we know for Y and T, 15 grams, and solve for B, 3.7 minutes. You get rid of the 3.7th power by doing the 3.7th root. Okay, and then write the equation. Just so you note, oops, it's 1 over 3.7. 3.7th root is the 1 over 3.7th power. So if you remember that you do the base and then it happens less than once, so you divide. So that's the way you had been doing it a long time ago. All of these methods work. Okay, for this one, I'm going to have, let's see. I'm sorry, not 15, 20. Initial value. ln the left side. Get rid of the e on the right side. And then k is ln of 3/4 over 3.7. Okay, so a note K is negative when the amount decreases, and B is less than 1 if the amount decreases. Okay, so final answer. Okay, so for the last two questions, you can use either formula. I'm going to do both. You don't have to do both, but unless you're told to. So if I have okay, so plugging in 12. Oops, 2 zeros. Type it in, you'll see. It comes out the same. I didn't just cheat. Grams. Okay, when will there be 10 grams? Again, same thing. This time we plug in 10 for y. I'm going to take the ln on both sides because that's what I usually do. But you can do log base 0.92519 if you want. Pop the exponent as I go. Okay. That's a terrible too. It's a miracle it's all the same. Okay, that was very long. But hopefully you can, like, just speed through to the stuff that's making you confused.